Dear students, I want to make you a short presentation about the oxoacids of nitrogen and phosphorus. I am Dr. Digna Varghese. Contents of the presentation is structure of oxoacids of nitrogen and phosphorus and the acidic strength of the acids. Oxoacids of group 15 elements. An oxoacid or oxyacid or ternary acid is an acid that contains oxygen. Specifically, it is a compound that contains hydrogen, oxygen and at least one other element, with at least one hydrogen atom bound to oxygen that can dissociate to produce H plus cation and the anion of the acid. So in the case of group 15 elements, an oxoacid of any group 15 element is a compound of that element. We know the members of the group 15 elements are nitrogen, phosphorus, arsenic, antimony and bismuth. Here the general formula of an oxoacid is shown in this equation, that is XOH. Any oxoacid, if it is a group 15 element or other group members, that should contain at least one hydrogen atom that is bonded to oxygen atom. And any oxoacid in general contains oxygen, hydrogen and other elements, at least one other element. In that particular compound, one hydrogen should be attached with the oxygen or bound to the oxygen atom. That is, any oxoacid should contain at least one OH group in its structure that can produce the H plus ion when taken in a solvent or in an aqueous solution, and the other part is the anionic part of the acid. Nitrogen and phosphorus forms a number of oxoacids. Most of them are recognized only in the aqueous solution or as their salts. Arsenic forms only two oxoacids. Oxoacids of antimony and bismuth is not known. Oxoacids of nitrogen. Here the table shows different oxoacids of nitrogen, and first one is nitric acid, second one is orthonitric acid, and the third one is nitrous acid, and fourth one is nitroxylic acid, and last one is hyponitrous acid. In this nitric acid, the molecular formula is HNO3. In this, oxidation state of nitrogen is plus 5. And orthonitric acid, that is having the formula H3NO4. In this, nitrogen is with plus 5 oxidation state. So nitric acid and orthonitric acid contains nitrogen with plus 5 oxidation state, but in the case of nitrous acid, formula is HNO2, that is minus 2 with oxygen and plus 1 with the hydrogen, therefore plus 3 with nitrogen in this acid. Nitroxylic acid, the formula is H2NO2 minus 2 with oxygen plus 1 with the hydrogen, therefore plus 2 is the oxidation state of nitrogen. And hyponitrous acid, the molecular formula is H2N2O2 minus 2 is the oxidation state of oxygen plus 1 is the oxidation state of hydrogen, and therefore nitrogen with plus 1 oxidation state. And in these compounds or acids, When dissolves in water, it gives corresponding salts. That is, nitric acid gives nitrate, so it acts as a monobasic acid. Orthonitric acid gives orthonitrate, so it acts as a tribasic acid. But in this case, orthonitric acid is not isolated, only its salt is isolated. Nitrous acid, NO2 minus nitrite is its salt, so it acts as a monobasic acid. Nitroxylate anion is from nitroxylic acid, so it is a dibasic acid. Hyponitrous acid is a hyponitrite is its salt, so it acts as a dibasic acid. To differentiate between the oxidation states of the central atom, that is, here the nitrogen is the central atom, oxoacid suffixes us, OUS, or IC, are utilized. The acids in which the central atom is in the lower oxidation states are known as acids, that is, nitrous acid, that is with nitrogen with +3 oxidation state, nitric acid with +5 oxidation state. So central atom with higher oxidation state end with ic acid. In hypous or hypoic acids, the oxidation states of the central atom is lower than the corresponding us and ic acids. We can see from the nitrous acid and hyponitrous acid. Nitrous acid in which the nitrogen is in the +3 oxidation state, and in the case of hyponitrous acid, nitrogen oxidation state is reduces to +1 oxidation state. Oxoacids of nitrogen. Here we are describing two oxoacids, that is nitrous acid and hyponitrous acid. Here the nitrous acid, its molecular formula is HNO2, and which is only known in solution and in the vapor phase. The structure, it is ionized in water, it gives nitrite as its salt, series of salt, and 1 proton, so it acts as a monobasic acid, and its structure is shown here. In this molecule, the OH bond length is 96 picometer and oxygen nitrogen bond length is 143 picometer, and nitrogen double bond oxygen bond length is 117 picometer. ONO bond angle is 100.9 degree, HON bond angle is 110.5 degree. So nitrous acid gives a nitrite series of salts, and it is unstable and disproportionate even on standing to nitric acid, nitric oxide and water. So it is very unstable acid. It decomposes to nitric acid, water and nitric oxide. Next oxoacid of nitrogen is nitroxylic acid or hydronitrous acid, which is an unstable acid and it is reduced to oxonitrogen acid. It has the formula H4N2O4. Containing nitrogen is in the +2 oxidation state. The corresponding anion is called nitroxylate, that is N2O4 4 minus or NO2 2 minus, NO twice 2 minus. Another one is hyponitrous acid with the molecular formula H2N2O2. H2N2O2, it's an isomer tautomer of nitramide, that is NH2NO2, and its structure indicates that it is in the trans configuration, that is 2 OH groups in the trans position. It is to be more kinetically stable. In this H2N2O2, nitrogen is in the +1 oxidation state. H2N2O2 is a weak acid since it contains two ionizable hydrogens, that is connected to the hydrogen atom connected to the oxygen atoms. So it acts as a dibasic acid and loss of protons, giving 2 protons and N2O2 2 minus as the anion, or it's a dibasic acid. It shows two resonance structures like this, or a tautomer of nitrate amide. Another two important oxoacids of nitrogen is nitric acid and orthonitric acid. In this nitric acid or aquafortis is another name of nitric acid which is derived from a Latin word means strong water. It is also known as spirit of nitre. It is highly corrosive acid. It is the most important oxoacid of nitrogen. Nitrogen is in this particular acid shows +5 oxidation state. In the vapor state, pure anhydrous nitric acid is a planar molecule. In aqueous solution, nitric acid acts as a strong acid. HNO3 dissociates in water to nitrate ion and proton. So it acts as a monobasic acid, that is its basicity is 1. It is a series of salts like nitrates, potassium nitrate, sodium nitrate, etc. can form from nitric acid with these alkali metals. Its structure is a planar molecule which is a resonance hybrid of the two structures given here, and in this the hydroxyl group, the OH bond length is 96 picometer and oxo-nitrogen bond length is 121 picometer, and oxygen nitrogen bond length is 140 picometer, and the oxygen nitrogen oxygen bond angle is 116 degree. Oxygen nitrogen oxygen bond angle, that is connected to the double bonded oxygen, that is with 130 degree, and HON bond angle is 102 degree. It is a planar molecule. Another important oxoacid, but it is not isolated, that is H3NO4 orthonitric acid. Orthonitrate is a tetrahedral oxoanion of nitrogen with the molecular formula NO4 3-. So it is a hypothetical acid. It is not observed. Oxoacids of phosphorus. Oxoacids of phosphorus, here we are representing the phosphoric acid, metaphosphoric acid, pyrophosphoric acid, hypophosphoric acid, phosphonic acid and phosphenic acid as the oxoacids of phosphorus. In phosphoric acid, which is also known as orthophosphoric acid, in which the oxygen is in -2 oxidation state and hydrogen is +1, -8 +3, that is +5 is the oxidation state of phosphorus. In metaphosphoric acid, -2 is the oxidation state of oxygen, +1 is the oxidation state of hydrogen, and +5 is the oxidation state of phosphorus. Pyrophosphoric acid, which is also known as diphosphoric acid, in this oxygen with -2 and hydrogen with +1, so 14 -14 +4 -10, so phosphorus is in +5 oxidation state. Hypophosphoric acid, oxygen with -2, hydrogen with +1, so -12 +4 -8, so +4 is the oxidation state of phosphorus. That is, this acid is also known as diphosphoric 4 acid. Pyrophosphoric acid is known as diphosphoric 5 acid. Another important oxoacid is phosphoric acid H3PO3. In this, -2 is the oxidation state of oxygen and +1 is the oxidation state of hydrogen. Therefore -6 plus 3, therefore +3 is the oxidation state of phosphorus. Another one is phosphinic acid is also known as phosphorus acid. Phosphinic acid is also known as hypophosphorous acid. Phosphonic acid is also known as phosphorus acid. Phosphinic acid is also known as hypophosphorous acid. In this, oxygen is in -2 oxidation state and hydrogen with +1 oxidation state. Therefore, phosphorus with a +1 oxidation state. These acids, when dissolves in water, it will ionizes and give anions such as orthophosphoric acid give phosphate, that is also known as orthophosphate. So it acts as a tribasic acid. Metaphosphoric acid give metaphosphate, it acts as a monobasic acid. Pyrophosphate gives tetrabasic acid, that is pyrophosphate anion. And hypophosphoric acid with hypophosphate ion, but it is not isolated. Phosphonic acid, that is phosphorus acid with phosphonate, so it acts as a monobasic acid. Phosphinate from phosphinic acid, that is also in the oxidation state of this is +1. Phosphinic acid gives phosphinate anion. Its basicity is also 1, so it acts as a monobasic acid. These are the important oxoacids of phosphorus. Here the phosphonic acid acts as a with the 2 ionizable hydrogens, so it has a dibasic acid. Phosphinic acid with a 1 ionizable hydrogen, so it acts as a monobasic acid. Phosphorus acid, that is also known as phosphonic acid, having the molecular formula H3PO3, in which the phosphorus atom is in the +3 oxidation state. Here H3PO3 contains non-ionizable hydrogen atom. These 2 hydrogens are ionizable hydrogens, so it acts as a dibasic acid with basicity 2. The IR spectra of the phosphorus acid molecules indicates that there is 1 pH bond and 2 POH bond. And here we can see when it ionizes in water, it will give 2 different kinds of salts, that is hydrogen phosphides and hydrogen phosphonates. That is, if it reacts with potassium hydroxide or any alkali metals, it will give corresponding potassium hydrogen phosphides or potassium hydrogen phosphonates, that is having the formula KH2PO3 and K2HPO3 respectively. In this molecule, it gives a tetrahedral like structure, and with H3PO3, the phosphonic acid or phosphorus acid, 1 phosphorus bonded to double bonded oxygen with the bond length is 150 picometer and pH bond length is 139 picometer, POH bond length is 155 picometer. Another acid is hypophosphorous acid. Hypophosphorous acid, that is HPA, which is also known as phosphenic acid. In this particular molecule, the phosphorus is in the +1 oxidation state. It has two non-ionizable hydrogen atoms. Only one hydrogen is ionizable, so its basicity is 1 and it acts as a monobasic acid. The IR spectroscopy of this particular acid molecule indicates that there is 2 pH bonds and 1 pOH bond. It gives only one series of salts. That means it ionizes with one proton and one series of salts, that is H2 PO 2 minus, H2PO2 minus and H plus. So it gives hypophosphites or phosphonates, that with potassium giving KH2PO2 plus proton. So hypophosphorous acid or phosphenic acid is a monobasic acid with a basicity 1. Next one is phosphoric acid, which is also known as orthophosphoric acid, in which the phosphorus atom is in the +5 oxidation state. It's a weak acid with the chemical formula H3PO4, in which the 3 hydrogens can be ionizable in water. So it acts as a tribasic acid with basicity 3. This molecule is tetrahedral structure. PO bond length is 152 picometer and POH bond length is 157 picometer. So it is a tribasic acid. So it can forms 3 series of salts. When phosphoric acid dissolves in water, it will give dihydrogen phosphates. Again it dissolves to give hydrogen phosphates. Again it ionizes to give phosphates. So with potassium metal it gives potassium dihydrogen phosphate, that is KH2PO4, potassium hydrogen phosphate, that is K2HPO4, potassium phosphates, that is K3PO4. So phosphoric acid, in which the phosphorus atom is +5 oxidation state, it is a tribasic acid and gives 3 series of salts, and it contains 3 ionizable hydrogens, so its basicity is 3. Phosphoric acid in general sense is a phosphorus oxoacid, that is in which the phosphorus atom is in the +5 oxidation state, which is bonded to 4 oxygen atoms which are placed at the corners of a tetrahedron. So its structure is tetrahedral. Pyrophosphoric acid, which is also known as diphosphoric acid, which is an inorganic compound having the molecular formula H4P2O7, and its structure is shown here, in which 2 phosphorus atom is connected with an oxygen bridge. It contains 4 ionizable hydrogen atoms, therefore its basicity is 4, so it acts as a tetrabasic acid. In this molecule, phosphorus is in the +5 oxidation state. When pyrophosphoric acid reacts with water, it is converted to orthophosphoric acid. Another important phosphoric acid is hypophosphoric acid, which it is a mineral acid with the molecular formula H4P2O6, in which the phosphorus atom is in the +4 oxidation state. Both pyrophosphoric acid and hypophosphoric acid is generally known as diphosphoric acid because it contains two phosphorus atoms. But in one case, pyrophosphoric acid contains extra oxygen atom and phosphorus with +5 oxidation state. Here, no extra oxygen atom and phosphorus is in the +4 oxidation state. This particular acid in the solid state, it acts as a dihydrate, that is H4P2O6 2H2O. Here the basicity of hypophosphoric acid is the same as that of the pyrophosphoric acid, that is 4. So it contains 4 ionizable hydrogen atoms. So it acts as a tetrabasic acid. Triphosphoric acid. Its molecular formula is H5P3O10. Its oxidation state of phosphorus in this acid is +5. Basicity is 5 because it contains 5 ionizable hydrogen atoms. Triphosphoric acid, pyrophosphoric acid, these are examples of condensed phosphoric acid. What is actually the condensed phosphoric acid? Two or more orthophosphoric acid molecules can be joined by condensation into larger molecules by the elimination of water. Condensation of a few units yields to oligophosphoric acids, while larger molecules are known as polyphosphoric acids. However, the distinction between the two terms is not well defined. Here we can see a condensed phosphoric acid. For example, pyrophosphoric acid, this is a triphosphoric acid molecule. Tetraphosphoric acids can be obtained by these types of reactions. For example, when phosphoric acid converted to pyrophosphoric acid with the elimination of water, that we are already studied in case of pyrophosphoric acid, that is treated with water giving orthophosphoric acid. Pyrophosphoric acid treated with a phosphoric acid giving triphosphoric acid with the elimination of water. That is simple condensation reaction. And here the triphosphoric acid reacts with the orthophosphoric acid to give tetraphosphoric acid with the elimination of water. These are condensed phosphoric acids. Condensed phosphoric acids, and some are condensation of a few units yields oligophosphoric acid, while larger molecules are called polyphosphoric acids. The backbone of a polyphosphoric acid molecule is a chain of alternating phosphorus, oxygen, phosphorus, oxygen, phosphorus. Each extra orthophosphoric unit, that is, one phosphoric acid reacts with the pyrophosphoric acid giving another condensed molecule, that is triphosphoric acid unit, that is given here. Here H3PO4, that is actually the molecular formula of orthophosphoric acid unit, that is condensed and forming here H2 and 4 oxygen atoms is there, but 1 hydrogen is missing. So 1 extra hydrogen atom, 1 extra phosphorus atom and 3 extra oxygen atoms are joined to this. So the general formula of the polyphosphoric acid is OH, then PO, OH, O, N times the last with H. That is the general formula. Metaphosphoric acid. the molecular formula is HPO3. It is a monobasic acid. It exists only in monomeric form when it is HPO3, but it does not exist as a monomer for a longer time, but it exists as a polymer, that is HPO3 n times. Here a linear form of the metaphosphoric acid, that is exists as a polymeric form, HPO3 n times, and it can also exist as a cyclic form, that is cyclic oxoacid, and a polymeric oxoacid. This is the polymeric, linear polymeric oxoacid. It is a trimeric cyclic oxoacid with the molecular formula HPO3 thrice, that is trimetaphosphoric acid. Another example for the cyclic oxoacid is tetrametaphosphoric acid, HPO3 4 times. So metaphosphoric acid is a monobasic acid. That means only one ionizable hydrogen is there, but it does not exist as a monomer for a longer time, rather than it exists as a polymer, that is with the general formula HPO3 n times. So it is exist in the linear form, also in a cyclic oxoacid form. Cyclic phosphoric acid. Condensation between the two OH units of the same molecule. On the other hand, it eliminates two hydrogen atoms and one oxygen atom, creating a cycle, as in the formation of trimetaphosphoric acid. Here one water molecule is eliminated and it forms trimetaphosphoric acid, that is HPO3 thrice, that is H3P3O9. The general formula of a phosphoric acid is Hn minus 2x plus 2 Pn O3n minus x plus 1, where n is the number of phosphorus atoms and x is the number of fundamental cycles in the molecular structure, and that is the minimum number of bonds that would have to be broken to eliminate all cycles. So the acidic strength of oxoacids explaining here. pKa values of acids. We know smaller values of pKa corresponds to greater acid strength. Oxoacids of nitrogen. In the case of oxoacids of nitrogen, hyponitrous acid H2N2O2. pKa1 value is 7.21. It is a dibasic acid, so pKa2 is 11.54. Nitrous acid is a monobasic acid with the formula HNO2. Its pKa1 value is 3.37. Nitric acid is HNO3. Its pKa value is minus 1.3. Here lower pKa value is with the nitric acid and the highest one is hyponitrous acid. So the order of acidic strength is nitric acid greater than nitrous acid greater than hyponitrous acid. pKa value with the smaller pKa value having higher acidic strength. So nitric acid is the most stronger acid among oxoacids of nitrogen. Acidic strength of oxoacids. Here we are discussing oxoacids of phosphorus. Acid phosphenic acid with molecular formula H3PO2. It is a monobasic acid, that is 1.24 is pKa value. Phosphoric acid, molecular formula H3PO3, it's a dibasic acid. Molecular form pKa value is 2 and 6.59. Phosphoric acid molecular formula H3PO4. It is a tribasic acid. So 3 pKa values, that is 2.21, 7.21, 12.67. Hypophosphoric acid H4P2O6. The pKa value is 2.2. It is a tetrabasic acid, so 2.8, 7.3, 10. Pyrophosphoric acid is also a tetrabasic acid with molecular formula H4P2O7, 0.85, 1.49, 5.77 and 8.22. Triphosphoric acid is a pentabasic acid with molecular formula H5P3O10. First one is a negative value, and then 0.89, then 4.09, 6.98 and 9.93. Among these acids, the value of pKa1 shows that triphosphoric acid is the least one. Then comes pyrophosphoric acid. Then with phosphonic acid, phosphenic acid. Then comes phosphonic acid. Then hypophosphoric acid, 5th position. Then 6th position is phosphoric acid. So phosphoric acid is a weak acid among these oxoacids of phosphorus, and the most acidic one among these is triphosphoric acid. When we considering the phosphenic acid, phosphonic acid and phosphoric acid, first one is phosphenic acid, that is higher acidic strength than phosphonic acid, and phosphorus acid or phosphonic acid is higher than orthophosphoric acid. Okay, that means smaller the pKa value, greater is its acidic strength. In the case of nitrogen family members, they show or form oxoacids with those elements, that is nitrogen, phosphorus, arsenic. Antimony and bismuth does not form any oxoacids. So the oxoacids of arsenic forms 2 oxoacids, that is arsenic acid and arsenous acid. In this arsenic acid, oxygen shows -2 oxidation state and hydrogen shows +1 oxidation state. Arsenic therefore shows +5 oxidation state. -8 here, +3, so +5 is the oxidation state for arsenic acid, and it takes when ionizes to give arsenate ion and 3 protons. So it is a tribasic acid. Arsenous acid is, the molecular formula is H3ASO3, oxygen with -2, so -6. Here +1 is the oxidation state of hydrogen, so -6 + 3, -3, so +3 is the oxidation state for arsenic. Arsenous acid also give arsenite anion with 3 ionizable hydrogens or protons, so it is acts as a tribasic acid. These are all about the oxoacids of nitrogen and phosphorus. Thank you for your attention.